Hi, I'm Ivan. I'm a principal software architect in Končar. We are mostly a hardware company dealing with the electric power sector, but we also have our own automation solutions and our own software development department, which I'm part of. So I'm going to be talking about our ISC 62443 product certification of our two SCADA systems and something about industrial control system security. Okay. So what are these industrial control systems? So ICS, or industrial automation control systems, or sometimes called operational technology as a contrast to information technology. So these are different SCADA systems, control centers, up to the leaf devices that control the physical process, various industrial embedded controllers. So in these systems, of course, availability is top priority. So we need to keep the electricity running, water running, everything, and our data is not that confidential. It is sometimes, but not that much. These are systems with expensive downtime and complicated upgrades. So nobody will let you upgrade software without testing again. Testing is expensive, downtime is expensive. And these are traditionally isolated systems, but really unprotected from the inside. We're dealing with legacy technologies. Most SCADA systems go back to the 90s. Really, they're legacy, they are upgraded, but most control system SCADAs are really from the 90s. These are low user count software, frequently badly architectured, outdated software, because you don't change it every year. You change control software maybe every 10 years, so frequently the operating system is out of support by then. But it's too expensive to change, and it takes too long. Once these systems were proprietary, nowadays mostly use commercial protocols, commercial hardware, commercial everything, and standard communications, so everything is mostly open. And there's this problem with personnel, so we have personnel with specific non-IT skills, which are not really security conscious, they deal with other stuff, and they deal with really specific systems, so every department, you have many silos, and every department has its own shadow IT, OT systems that the general IT guys won't touch, and everything is outsourced, essentially in the buildings. Okay, so critical infrastructure, we're dealing with critical infrastructure, and much of it is geographically distributed. Okay, we have power plants, some industrial sites that are localized, that you can physically protect easily. But most of it, like electricity, gas, water, it's geographically distributed. You really cannot protect it all. Electricity gas networks are transnational, so operated by many, many entities. Even in Croatia, you have like 4 transmission power operators and 20 distribution power operators. And now take it to the entire Europe, and the physical effects on these grids that are connected, they can cross borders. It doesn't matter if the IT networks are air-gapped, if it's a different country. And here's an example from this year. On 8th of January, we had an overload in one switch in the Mestino substation in Osijek, and it caused a cascading outage that split the East-West Europe system. So it took a few hours to merge it back, and not much load was lost, some in Romania, Bulgaria, some in Serbia, but this is fortunately because it could have been much, much worse. So this is the effect of, one switch, one computer system controlling that switch, and the switch fails. Okay, it's a procedural error. The report is really long, but it can cascade. It can cascade to entire Europe. And these cyber-physical systems, they're IT systems that control physical objects. This means we have inseparable physical and communication infrastructure. You cannot look at them as as separate objects. You can't look at them as a whole. So, okay, now we're dealing with standards. Let's go on to security standardization. I think this is a necessary formal foundation, of course, but just aiming for the papers is not really aiming for real security. And in our sector, the main standardization body is the International Technical Commission. Most of these standards are adopted in most Western countries now, even in Eastern, as national standards, even in America and Europe too. We have these 5-digit standard codes followed by some part codes, etc. And we are dealing in this presentation with the ISC 62443 standard, part 2.4 that we certified our two SCADA systems for. So this is security program requirements for industrial control system service providers. What is this really? These are really procedural requirements for providers of automation solutions like us. Okay, so what we certify are two SCADA products and their commissioning and maintenance procedures. So this is a procedural certification, not a technical one. Okay, this is the picture of the certificate. It was issued by TIV Nord. And this is the main part. As you can see, this is the standard, version 15 to 17, and these are these requirement groups that really tell you what you should certify, because this number means nothing because you can pick mostly it will. We were told that okay, you should pick most basic requirements, you shouldn't leave something unused if it's one of the basic rules that you use, but basically you can have two of these certificates that are completely different in details, with completely different certified requirements. This is important because I'll touch on this later because of tendering and requirements, formal requirements. Okay, so what's the standard? It's originally a US-based ANSI ESA standard. It's procedural standard, sometimes called ISO 2701 for ICS security. Okay, what does it do? You need to set policies, create procedures to fulfill requirements of this standard. You need to estimate your technical readiness levels. You need to establish your capabilities and allocate responsibility. And show a paper trail, most of all. Of course, define some architecture and security zone, but this standard deals with this technical stuff in more marginal way. You have other standards that deal with this really in detail. And you need to provide documentation for all of this, of course. This means checklists, guides, manuals, your policy documents, your procedural documents, and your individual paper trail of individual projects. Okay, so these are the certificate parts. There are more, but these are main parts that are certifiable in a way. So we have this 2.1, 2.4. This is establishing a security program and security program requirements. And asset owners, like utilities, should deal with these parts. System integrators should of course deal also with requirements, but with these detailed requirements with security levels and some secure product development life cycles. And developers, of course, deal mostly with component architecture and security product development. We certified again 2.4, so these are procedural requirements for commissioning and using our SCADA systems in a secure way as part of a bigger solution. Okay, so how does the certification process look? Well, these guys, consultants come, they, check what do you do in your business, you talk to them a lot, they answer your questions, and a few months later, they help you formalize your documents, and a few months later, another team comes and they have this huge checklist, and they go through it, they ask for documents, and you provide them. So it's important to be reasonable in choosing scope. What are you going to certify? Don't go for all requirements, because once you formalize them, you need to fulfill them. And skip what is non-applicable, skip what is unclear, skip what you don't have completely implemented. And most of all, in 2.4, you're certifying, in our case, a solution that's part of a complete system, so you have to refer to third parties that provide, an antivirus solution, firewall, whatever. You can have requirements for that, but you refer to third-party systems. They're not part of your core solution. So you're not certifying the entire hardware, software, process stack, physical system, whatever, and processes of the utilities. No, you're certifying your solution and how it can fit into a bigger secure system. Okay, now these are these requirements groups that you saw from the standard. We're going to go quickly through these. Okay, solution staffing, you have to inform your workers, they have to be certified, and we skipped a few requirements. This is strict management of change and permit to work, because our clients don't use it. You have a permit to work for a job, for a site, for some date range, but you don't have a permit to work for every change, software change, configuration change that you do in the software configuration. It's just not done like that. And we skipped the mandatory per project security contract assignment because, again, we don't have these kind of requirements, and it was not in scope. Okay, assurance is mostly about the capability to provide documentation, recommend procedures, verify these procedures, handling procedures. What we skipped, there's some parts about network scanning that were put in this assurance group, but we felt this was out of scope, so we skipped all this network scanning thing. Solution hardening, of course, ensure only necessary parts are present, remove everything else. You have to have capability to participate or conduct risk assessments and verify third parties. You have to have procedures to handle vulnerabilities. And we skipped some mandatory MFAs, some multi-factor authentication, and mandatory session locking. Session locking is not usually used. MFA should be used, but various reasons are given to why not. Mostly because these workplaces are fixed inside protected perimeters, local control levels can override, and system availability is most important. If somebody says, I couldn't turn off, the turbines, whatever, because the console was locked, that would be a big problem. So it's mostly left unlocked or with basic passwords are shared. Mostly it's physical security that protects you. But anyway, if you're in a site, you can already do damage on the local controls or even physical equipment. So yeah, you should protect control centers, but if you go into a substation, you can do physical damage directly. You don't have to go to the console or the automation system. You have enough real local controls like switches that to do damage. Okay. Network security, so you have to segment your network both geographically and functionally. So there's no reason why a substation from Osijek should talk to a substation from Zagreb. There's no reason why the phone system should talk to the SCADA system or whatever. So geographic and functional segmentation. Identify these trusted, untrusted interfaces, segments, protect everything that's untrusted, provide documentation, and ensure accurate time synchronization for logging and for our automation system. That's critical. What we skipped is least privilege administration of network devices and these requirements for administration of network devices because it's out of scope again. Okay, so data protection, of course, we don't deal that much with confidential data, real private data of persons. It is confidential, but not covered by GDPR directly on the transmission level. But still, you have to have capability to ensure data flows are valid, approved, encrypted, with mechanisms that are commonly accepted. Data needs to be safeguarded against disclosure, modification, etc. And we skip this, ensure data is permanently deleted when component is removed. We were not sure what this requirement really meant, and we don't want that. If someone needs to delete data, he will delete the entire PC or entire do any automatic data deletion. Okay, so configuration management, this is basically really important, and today in utilities a bit not a solved problem. You have equipment from the 80s to 2020s, different manufacturers. You don't have one system to track your configurations. And somebody goes there, it's an emergency, he changes something, maybe he doesn't even write it back, and it's not recorded anyway. When you go to a station, the as-built documentation is always different than the real state. And it should be synchronized. As I say, one of the really important requirements here is to have capabilities to keep the documentation current. Because after years, it really drifts. And maintain some inventory register of components. Okay? You have remote access, use commonly accepted solutions, provide instructions, provide information about all people, locations, times when you're going to access the system or be accessing the system, so about all remote access connections. And ensure approval from the client and use his procedures if he mandates them. Okay, event management means mostly logging and reporting. You have to document capacities to withstand some event storms and to log all security events. And we skipped some of this because it's mostly related to security centers, CMs, and real event management, security event management systems. Okay, account management, have a single integrated database, document editing procedures, and ensure continuous operations. For us, a main account cannot expire of an operator that's controlling a huge utility network. Okay, malware protection, it's standard, providing the documentation, ensure installation, ensure definition files are current, ensure the devices are free of malware when you install them, etc., etc. Backup and restore, of course, you need detailed procedures, you need to test these procedures, you need to verify, you need to do the backup and restores within the required time frame and ensure normal operation when backup is done. And these are two sections that we skipped, because wireless, we don't normally use it in our systems, and if somebody uses it, it's part of an external network, third-party solution, so he can certify it or do whatever. And safety instrumented systems, these are requirements mostly for safety controllers and lower-level embedded devices that are really safety devices that should turn off some process when something goes wrong. These are not usually applied to SCADA systems. SCADA systems monitor it from the center, but the protection functions run locally on these embedded devices. Okay, this is some of the documentation we needed to provide. So these two first are most important, probably your overarching security policy document and your security procedure book with detailed procedures. And then you have all the manuals and guides of your SCADA products, of your products, release notes, training materials, factory acceptance test or site acceptance test templates. You have to have a risk assessment methodology and evaluation. You can have some specific technical certificates for protocols, some third-party results, NDAs, examples of contract delivery notes, VPN permits, and additional third-party manuals. So a lot of documentation, but maybe these first two are the most important. Okay, let's touch a little bit on other standards. So there's the ISC 62351, and this is like the technical counterpart. ISC in our automation systems. For us, the most important part is it dealing with encryption for our protocols, but it also deals with general security architecture, SNMP monitoring, role-based access control, syslog, etc. This is not yet finished in all parts, but it's starting to take hold, and first encrypted automation protocols are being now asked on tenders and being put into place. But really, for now, these are not used in, I would say, 95+%, maybe even 99% of systems in Europe. They're not yet used, they have been recently completed. And, okay, so another standard is NERC-CIP. So it's the North American Electrical Reliability Corporation, and I like this one very much because it's really concrete. If you have a substation with voltage level above this and this, you have to have this. If you don't, penalty is this. So it's really binding. It's really different than European standards that are really recommendations. And we should have something like that, but we don't. But maybe we don't have to, because everybody wants to attack America, maybe not solve the equation. Okay, there's the German standard, more recommendation. It's an advisory standard, but it goes as a requirement in German tenders. So it pertains to electricity and water industries mostly. And there's the NIST. These are mostly recommendations and publications, and these two are, the 800 series is most important for us, and these two, like generic security and privacy controls and industrial system control system security, is 82 document. Okay, let's talk a little bit about tendering. So, okay, some security standards are present in most new tenders. Education requirements, personnel requirements are mostly well covered, at least. There's a lot of them. But technical, procedural, these requirements, standard requirements, are usually just some generic mention. You know, do the system according to 62351, 62443, and maybe 10 of these standards in one sentence, and that's it. And then the rest of the tender deals with, if it's for water, then it deals with the diameters of pipes, etc., on 30 pages. But these requirements are really not well specified in tenders in Croatia and even in international tenders. There's no reference to specific parts, no scope defined. What does this pertain on? The entire solution, on parts, on which parts, which part of the standard do you need to have certified? Because these are really different standards. These different parts are not the same thing. And today there are many competing standards and certification authorities, especially for personnel and education. Tender is under pressure to include some requirements in the tender. It's not easy to choose, and sometimes very specific requirements are used to control the tendering process, to kick out bids that you don't want. So if somebody asks for, you have to have this certificate, why really these 10? Why not something else if you have so many standards and certification authorities? So we would expect some law or something coming from the state level or EU level for some hardware recommendations, hardware requirements. Okay, so we're dealing with cyber-physical attacks. In a way, a combination of cyber attack and something physical, either a direct physical attack or exploitation of some specific physical process. So this is Stuxnet, you're exploiting the centrifuges, you're destroying them. In Ukraine, you're exploiting the electric grid, how is it constructed, and you're turning it off. And Trisis is really an important hack. It was relatively recent, a few years ago. These are safety controllers in the petrol industry in Saudi Arabia. It was this hack, Schneider Electric controllers, I think, safety controllers, and there was a hack on these controllers. They were disabled, and the attackers probably wanted to destroy it. They deal damage, but they made some error, and it was stopped. But I think very finally it was out of commission for a few days, so it cost a lot. Anyway, when you reprogram these endpoint leaf safety controllers protection devices, you can really deal real damage, because when you hack a control center, electric control circuits, yeah, you can turn off everything. Okay, so it will take a few hours to turn everything back on, but probably no real damage would be done. But if you reprogram these protection devices, which are also accessible from the network, because these protection engineers, they connect them, they check these devices, so everything is network, and they program them sometimes remotely. So this enables hacks to deal real damage. And cascading attacks, as we mentioned in the Ernestino case, which was not an attack, but it still made a cascade. If you have simultaneous attacks on specific elements, you can overload them, make instabilities somewhere else. If you overload one element, you take it out of service, leads to more overloads, and you can have a cascade. And you can have multi-service cascade, because you will have water without electricity if you need pumps. You have no electricity without gas. You saw it in Texas this winter, when their gas lines froze and they had no electricity and no gas, and it was relatively cold. You can have no traffic probably without electricity, no railway, no traffic signals, no way to coordinate, no heating without electricity or gas, etc. If you have no communication lines, you can't do remote control, you cannot coordinate your teams. And teams are now much smaller than they were maybe 50 years ago, when you have teams in every substation that could directly local control the substation. Okay, so we're talking about resilience, and I say resilience to what? What is the threat level? And is it cyber attacks, human error, malfunction, natural disasters, military, whatever? In electrical power systems, we have this criteria that's N-1 redundancy. It's purely technical criteria. It means any route between two cities, two whatever stations can fail, and any single site can fail. Any single substation, any single power plant can fail. And there should be no consequences. Even multiple, when you construct a system like this, even multiple outages that are unrelated probably wouldn't crash the entire systems or have bigger consequences. But if you take out two of the biggest power plants, lines, some related objects that are related in one place that hold the system in place, you could compromise the system. You could overbuild the system to withstand more outages, but it's expensive. It's really expensive. So N-1 is used as baseline, and the network is selectively reinforced in the most important parts. Oh. Okay, so what is cyber resilience? We should be able to withstand cyber attacks. So that means information security, but plus business continuity in the real physical world. And attacks are not random events. The N-1 redundancy is nice for protecting against random events, because you really need two random events to hit in one place or related elements. and you need two of them at the same time. But when you have attacks, these are conscious acts. The attackers will hit in the worst way, and they must find only one hole. And this naive bottom-up risk assessment that's done, like the probability of hack of one server, probability of hack of other servers, some numbers taken out from who knows where, then you sum all of these numbers. This definitely underestimates the real risk of something like this, because hacking these big systems can have a huge blast radius. That's multinational, that's so hacking big SCADA control center systems. We have these control center systems at the European level too, or some centralized antivirus solutions, or you'll see later supply chain attacks for antivirus and security solutions. You attack network equipment, some centralized backup and storage. Now in Croatia, I think you have some centralized government cloud. So, but if you hit that, you hit many government organizations at once, or a cloud provider. And as I said, in this case, physical effects can reach beyond borders of your system, your IT systems. So what do we have today? Utility systems, we have big complexity, big number of legacy devices, almost guarantees security holes. Thousands of kilometers of unprotectable infrastructure, and a complex stack. Decentralized operation, like cutting all the communication lines as it was done in the time of Nikola Tesla, is unworkable today. You have much, you don't have teams as large, you run the system much more efficiently, and you don't have as much leeway to go. Because you couldn't run an electric system today for an extended period of time manually. It would be really hard. And some worst case scenario in these utility systems would be a cascading advanced resistant threat, so means state level threat on multiple services. So simultaneous attacks on critical services, critical nodes, at times the biggest stress, outages in multi-utilities, maybe large-scale destruction of some sites, chemical, nuclear, water flooding, opening dams, crashing dams, disruption of communications. This would be probably very bad. We had some of this in Ukraine. We had mobile teams disrupted and electricity outages. Nothing was damaged. That was mostly a warning attack. Okay, so these supply chain attacks, these are common component attacks. You can reach many different entities, sectors at once. You had this SolarWinds hack recently, you had the Juniper supply chain attacks. Of course, everybody uses the same operating systems, so any hack that attacks one of those can attack your systems too, because everyone uses commercial components today. Everything is smart and programmable. You cannot verify anything. You cannot verify firmware. You cannot verify hidden processors, hidden baseband functions in your cell phone. And nowadays, these geopolitical blocks like China, US, Russia are trying to achieve hardware and software independence. And open source software and hardware could help here to not fragment the entire system. So we don't have in 30 years, Chinese software, American software, Russian software, operating systems, hardware, everything different. And okay, let's talk about automated systems. So intrusion detection versus intrusion protection systems. IPS is unacceptable in our systems. You cannot stop control commands, or you cannot stop my system because you think you have a security hole or a security attack. Most of these solutions cannot interpret our protocols, and even if they could, the real data semantics is hard. Because you interpret this protocol and it says, turn off switch 101. What does this mean? Who will you leave without electricity? How will it affect other systems? It's really hard. And everybody's talking today about some artificial intelligence anomaly detection. But this has a really hard problem with these type 1, type 2 error trade-offs. So it's hard to detect all anomalies with low error rate. You can detect all anomalies with a big error rate. You just detect everything that's a little bit suspicious. Or you can have a low error rate but not detect all anomalies. And for really fully automated systems, you would need to have general AI. As for self-driving cars and everything that you have been promised, that will be in a few years, it won't be in a few years. But you can do something with this, because it can help filter events for a human, but it's hard to learn from past data in our systems, have a normal operation for 10 years, and then you have an emergency that's really specific, that it's not in the past data. And that's just the moment that you need a system like this to operate perfectly. When you have emergency, systems are crashing, your engineers that normally never send commands or log into the software will log into, you will do many actions that are not normal, and the AI will raise all of this as an anomaly. And you should not have alarm storms because your operators will just dismiss all of the alarms. And for all of these systems, these are mostly centralized today. But we should allow some redundancy and possibility of island operation in these systems. When everything goes down, the system fragments, your centralized security systems means nothing if you cannot reach all the parts of the entire physical system. So it should have some architecture according to the physical equipment zones and program plans. And last slide, some best practices. There is no, of course, no silver bullet, no magic security bars that you can buy and just plug in. You need to use defense in depth and security by design, not hide behind obscurity, what we have been doing for a long time in our sector, because it's very specific. Don't spread fear, uncertainty to sell your products. Understand your process, both sides, IT and OT. You need really, in our case, computer scientists, computer engineers that understand the physical process, the electrical process, the water process, whatever we are dealing with on the other side and how it will affect. Implement all of these technical security measures and more would fit on the slide. Make some risk assessments, assign some priorities, push for some actions with your management, but don't let security interfere with the primary process you're doing. Don't be too expensive, don't be too inconvenient, because people will avoid you and avoid your security and make shadow IT systems whatever they need to do their job. Okay, that's it. Thank you. Any questions?
Može na hrvatskom?
Da može.
Thank you. Govorili ste o standardima u OT-u i govorili ste o tome da se neki mandatori mogu preskočiti. Tipa multifaktor organizacija.
A ne mandatori, u tom standardu ništa nije mandatori. Imaš grupa i nekakve requirements i ti kao biraš od toga, a nije u standardu pisano šta moraš izabrati. Nama su ovi savjetovali, dobro, ne možeš ostaviti naravno ove očite dijelove prazne, podijeljeni su basic requirements i nekakav advanced ili ne znam ništa.
Kako očekujete vi da će se onda OT security standardi približiti IT security standardima? Još ste rekli malo prije u slajdu da ne implementiraju se low privilege access, ali danas je OT spojen sa IT-om.
Nisam rekao da se ne implementiraju. Mi ovdje nismo certificirali, mi certificiramo svoje SCADA rješenje. Znači nekakva, management network uređaja nekakvih, to je već out of scope za nas. Mi možemo neke savjete dobro reći, moralo bi se to tako raditi, ali mi smo te stvari jednostavno preskočili. U konačnici ti ovakvu stvar radiš, dobiješ na kraju neki papir, možeš tražiti 100 od 100 tih stvari, nećeš nikad završiti, možeš raditi 70 od 100 pa ćeš napraviti certifikaciju u razumnom vremenu. Tako da mi smo preskakali neke stvari koje su bile sumnjive, nepokazljive, negotove i tako dalje.
Kad u praksi očekujete malo veći security standard na OT strani? 10, 20, 40 godina?
A ne znam, kad se uloži u ova, sad je teško tebi teško ljude dovući sa tim plaćama, iskreno. Ovdje, između ostalog, utility sektor, teško je i vani. Tako da ne znam, kaže se, naravno mora se propisati sa strane zakona, to je najbitnije, ali ono će se odozgora iz menadžmenta, alocirat će se pare i naravno sve će se potrošiti na nešto razumno. Ali do tada da se ljudi imaju 1000 problema i još što vam pokazujem, znači jedna stvar je, mi možemo raditi na IT security. Ako ja danas dođem, ja tu uvijek pričam priču, dođem u železariju, dajte mi 100 metara lanca narežite na segmentu od 10 metara, nas trojica to raspodijelimo, odemo na 3 točke u Hrvatsku, u istom trenutku podne to bacimo preko ograde. I mi izbacimo cijelu Hrvatsku za 100 metara lanca metalno svačega. Znači to nije fizički zaštićeno, dođemo na daleko odminiramo, daleko od usred Velebita. Ne znam, 5 najbitnijih daleko od isto vrijeme ginemo za rad. Postoji puno načina i ne znam kako to sve skupa stoji, na neki način stoji jer je zatvoreno jer ljudi unutar toga ima se povjerenje. Da ne govorimo o insajderima, insajderi bi mogli tu bilo šta.
Da čujemo insajdere.
Evo. Da vidimo malo. Ovako, ja sam ovo shvatio, mislim da sam dobro shvatio, ovo je zapravo smotrišta vas, proizvođača, skala opreme, odnosno aplikacije i vi ste...
I mi mislimo da, što se tiče standarda, možda sam to zbrisao, mi mislimo da ove 6.2.4.4.3 da bi zapravo asset owneri, kao što ste vi trebali ići u certifikaciju, da je to puno jače od toga da vi tražite pojedinačni certifikat od proizvođača i kažete, evo ovih 10 komponenta kad ja skupim na hrpu, to je sigurno.
Definitivno ovo je nama. Dakle, uzmemo vašu aplikaciju i znamo u tim segmentima je to sukladno 62.4.4.3, tome i tome. No, međutim, nas, odnosno meni to je da nema zakona, zapravo nas je od ZK, zakona o kibernetičkoj sigurnosti operatora ključnog prostora obvezuje. Tako da nekakvih poslali su nam audit od 130 kontrole i te kontrole se već jesu zapravo i mapirane na kontrole ovoga standarda i mi se zaista trudimo i fizički i financijski i organizacijski uskladiti svoje procese sa zakonom o kibernetičkoj sigurnosti, mada recimo smotrišta penala i kazne, čak bi nam se više platiti svake godine platiti kaznu. Dobro, na stranu sada.
Mi to možda neće, da komercijalno se neće platiti.
Svjesni smo zapravo mogućih šteta, neoportunitetnog troška, šteta koje mogu nastati tako ne provodimo sve te aktivnosti i sve te mjere. I ono što nakon zapravo nekako, ciljane 100% biti sukladan svakom detalju tih propisanih mjera, paralelno već i prije toga mislimo krenuti zapravo u ovom smjeru i prema sukladnosti procesa i sa ovim standardom, a već i u ovim tenderima koji su izravno usmjereni na sukladnost poslovanja sa ZKS-om, tražimo zapravo, ali ovak, 4 crtica, ali smo nešto rekli, ne?
Ali samo je problem da tenderom da kako to validira.
4 stvari, jako smo precizni zapravo u ovim ZKS zahtjevima. To gađamo 100% jedan na jedan.
Mislim, Hobbs je daleko najjači utility u Hrvatskoj po tom pitanju, ovi svi drugi se mogu, mislim, sakriti u principu. Kad dođete u vodovod, to su ljudi bez uvrede, realno na lopati, mislim, ali je tamo teško naći uopće nekoga etivica, to su ADSL spojen direktno na upravljački SCADA sustav od vodovoda i takve stvari, tako da. Ima tu puno mjesta za napredak u ovim drugim utilitima. Primjer, Hobbs tjera EC, tjera i međunarodne organizacije, u konačnici Hobbs je dio europske mreže i mora se ponašati u skladu s njima. Nekakav vodovod tu lokalni se ne mora ponašati u skladu s njima.
Baš, ajde, neću prisiliti tim zakonom. Proveli smo, nedavno dovršili smo uspješno projekt u okviru kojega je, pa usuđujem se reći, možda i najveća procjena rizika u Hrvata ikada napravljena. Ugovarali smo zaista sve napravljene i distribucijski dio isto elektroenergetskog sustava Republike Hrvatske. Baš smo si dali truda, ima nas to više u ovoj sobi koji smo aktivno umrli na tom poslu.
Da li to znači da sad vi mijenjate svoje SCADA uređaje po operaterima sa certificiranjem?
Mijenjaju se kad one naručavaju, a generalno ja nisam krenuo da se povećali ciklusi. Znači ciklusi javljaju da se i dalje gledaju kao recimo 10 do čak 20 godina. Za softwaresku opremu, znači za primarnu opremu je to možda i 50 godina. Znači između opremu 20 godina, kod nas je sad, ajde, mi pokušavamo to nagurati na 10 godina. Vama je realno da kad vi neki sustav po sajtu, vama neće dati neko da učite ponovno tu, da nešto dirate. Ne diraj dok radi, pusti tu, kad dođe vrijeme za 5 godina, budeš ti javljen.
Znači XP i dalje, jel?
XP vam je u... Sad nije sve XP nije bitno, ajde. Neću tu kolegu uvrijediti.
Evo, mi smo.
Šta je na radnim stanicama u nacionalnom centru?
Napenale su offline.
Evo čisto komentar od strane korisnika ovih uputa. Mislim, mi uistinu koristimo kao uputstvo, odnosno guideline. Tako da ne koristimo ih za tendere, nije važno biti certificiran, važno nam je osigurati recimo naš proizvodni pogon, te stvari. Tako da, ova stvar je dobra, da će to biti usklađeno s nečim, neće nikad biti usklađeno jer je namjena, mislim, IT je drugačije nego što je OT. Ono što je važno razumjeti, ne? Najbitnije od svega, ovo moraju biti guideline. Sad, neke stvari možete primijeniti, neke ne možete, ali morate biti svjesni svega. I sad, gdje je škript, tamo treba uložiti novac, tamo treba uložiti tehnologiju, tako da treba nam još puno godina da, i nikad naravno nećemo osigurati
U Hrvatskoj škripi trenutno su ljudi,
ali
s inženjerima koji nemate dovoljno.
A ima jedna stvar, recimo, ti sam vas pitao da li imate neki use case cloud, dakle, uistinu...
Ja sam je cloud za hranu.
Povezujete sa cloud servisima, dakle mi danas sve više toga kao ima, sve su to neki use case.
Kod nas je cloud, evo, mogu ti reći, negdje se pokušava gurati za nekakve analitičke i takve nekakve rješenja, da ti recimo iz svojih nekakvih centara gurneš dio podataka o nekom cloud, pa nekakve izvještaje vadiš, ali čak i to se mrko gleda na to, a kamoli da se upravlja kroz neki cloud, kroz neki third party rješenja, znači ne, tu je hardware i sve ovo nam od strane utility i mora biti njihovo i mora i komunikacijski putevi, znači imate optiku položili u sve te vodove, znači oni imaju svoje komunikacije, svoja računala, svoje sve, cloud.
Pitanje je koje podatke guram, ne? Na kraju to postane samo sebi svrha, imamo cloud nešto, a u principu i koristimo onda analitiku. Super, imamo analitiku, imamo cloud servis, a zašto to radim? Ne pojma.
Radite na menadžmentu da si sprinta, ali ljudi šaljem izvještaj, ono gledaju.
To su te stvari koje treba razlikovati. Tehnologija će tu pomoći, ali treba nešto malo više reći.